What if an asteroid hit the Earth? Imagine a morning like any other. You wake up, sip a hot cup of coffee, and gaze out at the clear blue sky through your window. But suddenly, a brilliant red streak cuts across the sky, trailing a long column of smoke like a comet's tail. Just minutes later, the ground shakes violently, the sky turns a deep crimson, and a massive shockwave sweeps through everything in its path. Have you ever imagined such a scenario? The idea of an asteroid colliding with Earth may sound like something out of a Hollywood blockbuster, but in reality, it is a genuine threat. 66 million years ago, a giant meteorite ended the age of the dinosaurs, and it could happen again. The question is not if, but when. And more importantly, what can we do to prevent it? Let's explore this terrifying yet realistic scenario. What would happen if an asteroid struck Earth? How devastating would the impact be? And could humanity survive? Every day, hundreds of small meteoroids enter Earth's atmosphere without us even noticing. These cosmic fragments can range in size from a few centimeters to several dozen meters. However, instead of causing catastrophic destruction like in science fiction movies, most of them burn up in the sky and disappear before reaching the ground. Earth is shielded by a thick atmosphere, acting as a giant protective barrier. When a small asteroid hurtles toward Earth at speeds of 70 km/h, dozens of times faster than a bullet, it collides with air molecules, generating immense pressure. The temperature can reach thousands of degrees Celsius, enough to vaporize most of the object's material. As a result, it glows brightly, creating what we call a meteor. If the meteoroid is slightly larger, it may form a massive fireball in the sky, known as a bolide, before completely disintegrating. These events occur daily, but because most take place over oceans or uninhabited areas, they often go unnoticed. Although most small asteroids are entirely destroyed in the atmosphere, a few may survive and crash to Earth as meteorite fragments. When this happens, the impact is usually localized, depending on the object's size and speed. The Tunguska Event, 1908. One of the most well-known examples of a small asteroid causing significant damage is the Tunguska event in Siberia. A celestial object, approximately 50 to 60 meters in diameter, exploded in the air, generating a shockwave equivalent to 10 to 15 megatons of TNT, 1,000 times the power of the Hiroshima atomic bomb. While it did not leave a crater, the explosion flattened over 2,000 square kilometers of forest. Fortunately, there were no casualties due to the remote location. The Chelyabinsk Event, 2013. A meteor about 20 meters in diameter exploded at an altitude of approximately 29.7 km over Russia. The resulting shockwave shattered the windows of over 7,000 buildings and injured more than 1,500 people due to flying glass shards. While small asteroids are not large enough to cause global disasters, they can still inflict significant damage if they strike a densely populated area. Scientists are closely monitoring celestial objects over 20 meters in diameter to predict their trajectories and provide early warnings in case of potential collisions. In summary, most small asteroids are harmless visitors to Earth, burning up in the atmosphere and transforming into breathtaking streaks of light in the night sky. However, the few that do survive and reach the surface can produce terrifying explosions, reminding us that space remains an unpredictable and perilous frontier. In the vastness of space, asteroids ranging from 25 meters to 1 kilometer in diameter are not uncommon. They are too large to be entirely burned up in the atmosphere, yet not massive enough to cause global extinction. However, if such an asteroid were to strike Earth, the consequences could be catastrophic, enough to wipe out an entire city or trigger a major natural. Unlike smaller meteoroids that burn up in the atmosphere, medium-sized asteroids typically survive their descent and create massive explosions upon impact. The intensity of the explosion depends on the asteroid's size, speed, and angle of entry. These asteroids can explode in the air before reaching the ground, producing a massive shockwave, Create a large impact crater if they are big enough to survive atmospheric entry. Trigger earthquakes or tsunamis if they land in the ocean. History has recorded such events, and their aftermath serves as a sobering reminder of the destructive power lurking in space. On June 30th, 1908, a meteorite approximately 50 to 60 meters in diameter crashed into the Tunguska region of Siberia. When it exploded at an altitude of about 510 kilometers, a massive column of fire erupted, and the shockwave from the explosion leveled over 2,000 kilometers of forest, an area equivalent to a large city. Explosion power: 10 to 15 megatons of TNT, over 1,000 times the strength of the atomic bomb dropped on Hiroshima. Shockwave impact: flattened millions of trees within a 30 kilometers radius. Gni. See, a lucky escape. The explosion occurred in an uninhabited area. Had it struck a populated region, the consequences would have been catastrophic. What's terrifying is that a similar event could happen anywhere on Earth. Since about 70% of Earth's surface is covered by oceans, it's more likely that a medium-sized asteroid would crash into water rather than land. While this might seem less dangerous, the reality is that it could trigger a devastating tsunami. Beyond. If an asteroid between 100 and 500 meters in diameter were to hit the ocean, it could create a water column several kilometers high, generating tsunamis hundreds of meters tall that spread across the sea. These massive waves could devastate coastal cities, wiping out entire regions and causing the deaths of millions, much like a great flood. The consequences wouldn't stop at rising sea levels. The impact could also trigger earthquakes and alter the regional climate for years. If such an event were to occur in the Pacific or Atlantic Oceans, where major coastal cities like Tokyo, New York, or Miami are located, the damage would be unimaginable. If an asteroid between 200 and 500 meters in diameter were to collide with a densely populated area, the consequences could be worse than the most powerful nuclear explosions ever recorded. It could obliterate an entire city in seconds. Massive fires would spread due to the extreme heat generated by the explosion. Millions could die instantly from the shockwave. Dust and debris could block out the sun, affecting the climate for years. Scientists estimate that if an asteroid approximately 1 kilometer in diameter were to impact Earth, it could trigger an asteroid winter. Dust and ash from the explosion would spread across the planet, blocking sunlight, lowering global temperatures, and throwing Earth into chaos for years. Currently, space agencies such as NASA and ESA are actively monitoring near-Earth asteroids to detect potential threats. Some proposed defense strategies include DART mission, 2022. NASA successfully altered the trajectory of a small asteroid by crashing a spacecraft into it. Gravity tractor method, using a spacecraft to fly close to an asteroid for an extended period, slowly altering its orbit. Nuclear detonation, a last resort option that could destroy or deflect an asteroid if all else fails. Although the probability of a medium-sized asteroid colliding with Earth is low, if such an event were to occur, the consequences would be devastating. Therefore, early detection and preparedness are crucial. Asteroids ranging from 25 meters to 1 kilometer in diameter pose a real threat to humanity. While they are not large enough to wipe out civilization, they could still destroy entire cities, trigger massive tsunamis, or create an asteroid winter. History has proven that these events have happened before, and they could happen again. The question is, are we prepared to face them? Space is an eternal battlefield where celestial bodies collide, fragment, and sometimes find their way to Earth as if by fate. Asteroids larger than 1 kilometer in diameter are no longer just a localized threat. They are planet killers capable of completely reshaping Earth. If such a massive object were to crash into our planet, the consequences would extend beyond regional destruction and could lead to mass extinction, just like the event that wiped out the dinosaurs 6 million years ago. Large asteroids, measuring 1 to 10 kilometers in diameter, travel at speeds of 20 to 40 km/h. Upon impact with Earth, they would release energy equivalent to millions or even billions of atomic bombs, far surpassing any explosion humanity has ever witnessed. Immediate consequences would include a global shockwave. The force of the explosion could obliterate everything within hundreds of kilometers. Extreme temperatures. The impact would generate a fireball hotter than the surface of the sun, incinerating everything in its path. A massive impact crater. If the asteroid is over 5 kilometers in size, it could create a crater tens of kilometers deep, turning the entire region into an inferno. Tsunamis hundreds of meters high if the impact occurs in the ocean. Earth's history has already recorded one such impact, and it changed life on the planet forever. Approximately 66 million years ago, an asteroid about 10 kilometers in diameter crashed into what is now the Yucatan Peninsula in Mexico. This impact triggered one of the most catastrophic mass extinctions in Earth's history. Explosion power, equivalent to 10 billion nuclear bombs detonating simultaneously. D. Chicxulub crater, 180 kilometers wide and several kilometers deep. Dust and debris. Cloud, covered the entire atmosphere, blocking sunlight for years. Asteroid winter, global temperatures plummeted, plant life perished, and the food chain collapsed. Outcome: over 75% of all species on Earth, including the dinosaurs, became extinct. Chicxulub was not the only impact event in Earth's history, but it serves as a grim reminder that such disasters can happen again. If an asteroid over 1 kilometer in diameter were to hit Earth today, the consequences would be devastating. Scientists have simulated such a scenario and found Phase 1. Initial explosion. If it hits land, a fireball hundreds of kilometers wide would incinerate entire cities and surrounding regions. If it hits the ocean, massive tsunamis hundreds of meters high would engulf coastal areas within hours. Phase 2. Shockwaves and earthquakes. Shockwaves would ripple across the entire planet, felt thousands of kilometers away. Magnitude 9 or 10 earthquakes could occur worldwide, toppling buildings and infrastructure. Phase 3. Asteroid winter. A colossal amount of dust would be ejected into the atmosphere, blocking sunlight for years or even decades. Global temperatures would drop dramatically, leading to widespread plant and crop failures. Many animal species would perish, potentially triggering a new mass extinction event. These effects could alter the entire ecosystem, and human civilization might not survive the aftermath. Scientists are aware of this threat and are developing several methods to protect Earth. Early warning systems. Organizations like NASA and ESA continuously monitor near-Earth objects, NEOs. Altering an asteroid's trajectory, the DART mission, 2022, successfully changed the course of an asteroid by crashing a spacecraft into it. The use of nuclear weapons to destroy or deflect an asteroid is also under research. Asteroid resource mining. Some experts suggest mining asteroids for resources to change their trajectory before they become a threat. While these solutions are still being tested, preparation is critical. A single miscalculation could spell disaster for humanity. Earth has experienced many major impacts throughout its history. The question is not if another asteroid will strike, but when. What happened to the dinosaurs 66 million years ago is a stark reminder that our planet remains vulnerable to cosmic threats. But unlike the dinosaurs, humans have technology, knowledge, and, most importantly, the chance to prevent such a catastrophe. The real question is, will we act in time before it's too late? Some rare impacts do not just affect a single region, but have the power to wipe out most life on Earth. A super asteroid, an object over 10 kilometers in diameter, could dramatically alter the planet's climate and geology. This is precisely what happened 66 million years ago when the dinosaurs, Earth's dominant species for over 160 million years, were wiped out almost instantly. So what would happen if a similar asteroid were heading toward Earth today? A super-asteroid can travel at speeds of 30 to 50 km/s. Upon impact, it would unleash an explosion billions of times more powerful than the atomic bomb dropped on Hiroshima. The energy released would be equivalent to millions or even billions of megatons of TNT, instantly annihilating everything within thousands of kilometers. Immediate aftermath of the impact. Global shockwaves and earthquakes. The Earth's crust would tremble, causing magnitude 10 to 12 earthquakes worldwide. 100-meter-high tsunamis. If the impact occurs in an ocean, entire coastal continents could be submerged. Fires and firestorms. The explosion's heat would ignite forests, cities, and all life within a massive radius. But this would only be the beginning. A collision with a super-asteroid wouldn't just devastate Earth's surface, it would alter the global climate in ways that could never be reversed. When an asteroid impacts, trillions of tons of dust would be ejected into the atmosphere, blocking sunlight for decades. Global temperatures would plummet, triggering an unexpected ice age. Without sunlight, plants and vegetation would die off, breaking the ecosystem. Herbivores would perish first, followed by predators, and eventually humanity itself. Ash and dust mixing with chemicals would create acid rain, wiping out countless life forms. Oxygen levels would drop, making survival nearly impossible for many species. After the dust settles, CO2 from wildfires and volcanic eruptions would cause abrupt global warming, leading to climate imbalance lasting millions of years. If humanity survives the initial catastrophe, we would be left with a barren world incapable of supporting food and water supplies, pushing civilization to total collapse. The Chicxulub super-asteroid serves as a prime example of the destruction a large celestial body can cause. However, history has recorded other similar-scale impacts, though less well-known. Vredefort impact, 2 billion years ago, South Africa. Asteroid diameter, over 10 kilometers. Largest impact crater on Earth, 300 kilometers. Completely reshaped early Earth's geology. Sudbury impact, 1.85 billion years ago, Canada. Caused an explosion even more massive than Chicxulub, leaving a 250 km wide crater. KT event, Chicxulub, 66 million years ago. Wiped out 75% of life on Earth, ending the age of dinosaurs. These impacts prove that Earth is not immune to cosmic disasters, and it could happen again. Scientists and space agencies worldwide, particularly NASA and ESA, are monitoring near-Earth objects, ANEOs, to assess potential threats. Several defense strategies have been proposed. A spacecraft could collide directly with an asteroid to nudge it off course. DART mission, 2022, successfully tested this method by altering the trajectory of the asteroid Dimorphos. A spacecraft could fly near an asteroid for an extended period, exerting a small gravitational pull to gradually change its path. Some scientists propose using nuclear explosions to destroy or deflect an asteroid. However, this poses a risk, breaking the asteroid into smaller fragments that could still impact Earth and cause localized disasters. While these strategies are still under development, none guarantee 100% safety. According to NASA, no known super-asteroid poses a risk of collision with Earth in the next 100 years. However, thousands of objects remain undiscovered, and a single miscalculation could lead to an actual doomsday scenario. We cannot stop a super-asteroid if we fail to detect it early enough. That's why investing in asteroid tracking and research isn't optional. It's a necessity to protect our planet. Dinosaurs were wiped out because they lacked the technology to change their fate. But humans have the ability to alter history, if we act in time. Asteroids have reshaped Earth's history before, and one day it could happen again. But unlike the dinosaurs, humanity has the intelligence and technology to identify and prevent this catastrophe before it's too late. The question is not if, but when. Will we detect and prepare in time? What do you think about this threat? If an asteroid were heading toward Earth, Would humanity be capable of protecting itself? Share your thoughts in the comments below. If you found this video interesting and informative, don't forget to like, share with your friends, and subscribe to the channel so you won't miss our next exciting content.